Good morning, everybody. This is Obi-Wan Pez for Simplex Pachinko. We are tonight, or this morning, looking at doing some mathy type stuff, so if anybody has any questions, feel free to drop them in chat. Have another subscriber as of yesterday, so thank you very much, Danny. Snuck that one in while I was offline. I was thinking we'd start out with some Project Euler type stuff. I had some ideas on how to get this last one without cheating, which I totally hard-coded. Totally hard-coded what we have here. So it is not ideal. This is sort of a kludge method of getting this done, which is to say, like, I could just input the particular numbers and manually type in all this stuff, but it's not really helpful. I guess just to look at it and make sure that yeah, that was not the one I wanted you to run. Cool. You're gonna run this one. Cool. Prime list is a none type. Well, that seems like a bad idea. Alright, so just as a reminder, 2520 is the smallest number that can be divided evenly by each of the numbers from 1 to 10 without remainder. What is the smallest positive number that is evenly divisible by all numbers 1 through 20? So the way that I was doing this before was to find a list of prime divisors. So it's looking like I was trying to kind of find an answer and then work backwards to see if this was going to work. This was our candidate number, essentially. And then we were going to like manually do this. So that seems less interesting or helpful to me. I'm just going to get rid of all this. Alright, so we're going to get rid of all that. Alright, I had a few ideas of how to get this done in the last couple of days. I just kind of poked around and said, let's take a look at the question again, and then let's come back to it and try to revisit in our head, see what exactly kind of thing we were trying to get. Alright. So the way that I wanted to do this, as of this morning, I guess, was I could either find a list of primes and then do a prime factorization based on the numbers that we're using from 1 through 20. So essentially you say, okay, if I'm gonna, what was it, by evenly divisible by all the numbers 1 through 20. So I was thinking like, okay, well, we'll start with 2, and then we'll say, okay, 2 needs a power of 1 based on this. And then the next number, next prime, is going to be 3, and then 5, and then 7. And how many times do we need to evenly divide this thing? And so it's always just going to be exponents. And then that could work. It's its own thing. Man. Just never ends, getting hair and everything. And then a different option could be that we could just use the LCM tool. Because I'm pretty sure Python has an LCM tool. So I don't even want all the prime divisors. I just want right, what's the least common multiple product of some n? So that's going to be all values from 1 up to whatever n is. We're going to find the LCM of the product of all of those individual numbers. Okay, so I need a Python console first to make sure that I can... Do I need that console? No, I need a Python console. Okay, so... Uh-oh. Alright, we always import math. Cool. Really? Math dot LCM. Okay. Okay. We could just literally make a tuple. Wow. Let's see if we do this as like a matrix type thing. Does that? No. Okay. So that's going to yell at me. But we could just literally take this as a tuple and say like, list out every single number from... Okay, so we want math dot LCM of okay, now this is where we get into the I don't know quite how to do this part. Okay. While we're just going to make up some I value, which unresolved reference. Okay, so start I equals 1. Okay. I'm gonna look at the previous ones. So when we did some of this other stuff, how do we make strings, right? I don't want a string. How do we make a comma separated variable list? Did we? Have we ever? By considering the terms of the Fibonacci sequence from the sum of the even valued terms. Okay. No, we're gonna run 04 or 02. Print fib sequence. Cool. Man. Put a halt. Oops. Pfft. Cool. I just slapped the enter key. Okay. Step through. Just maybe. Really? It's not defined? Rerun. Debug mode. No. There we go. Or something. No. Okay. Rerun. How do you step execute? Debug. Stop and rerun. Yeah, okay. There we go. So we do this. Pause. Nope. Okay. Playing a lot of Harris Heller. Is that just what we're playing? Alright, we're gonna hit the surprise me button again. There we go. Had to make sure that was actually working. Okay. So rerun. Try again. Fibonacci sequence 1, 2, 3, 5, 8. All right. Step over. All right. Integers 10. Sum Fibonacci even. Okay. So it skips that. It goes on 13, 21, 34. 55. Okay, so this is just okay, this is appending, jeez, as a string. And then as a list. Okay, it is an appending list. So we can do this for number 5 as well then. Alright, so while I is less than m plus 1. Wait, we just want a list of the integer. Oy. From 1 to n. Range. That's it. Cool. I don't even need this I thing. We can just get rid of this entirely. Okay, we want to take the math LCM range 1 to 1 to n. And that might be it. Unresolved reference candidate. We don't need it anymore, right? We do need something in here to say like this should be equal to. We need an input. And just like every other one before it, pretty much, right? So... yeah, input, number to be factored, whatever. So for number 5, this is input of integers through what? Okay. That's going to be n equals. Right. TBF equals input. Yep. And then we want LCM product. Alright, question, is it that easy? Probably. Alright, LCM of integers 1 through 10. Let's make sure it works properly. Nope. Okay, string object cannot be interpreted as an integer. Right, so then we want n equals int n. And then we rerun it. Nope. Okay. Oh, range is an iterator. Cool. That's not how it works beyond Python 2. Okay, cool. Okay. Okay. List range. What's this? Expected type supports index got list int instead. Alright. LCM of given array elements. Okay, maybe we have to do this manually? I really hope not, but cool. Oh, Python. There we go. Yeah, it's stepping through and doing a for loop. Oh, lovely. Okay. While I is less than, we do need the I after all. Plus 1. Why is that throwing a red? Indent expected. Ah, that's not the one. That's fine. So while I is less than n plus 1, what we want is for it's been so long since I've done programming. Okay. We want to make a list int list of I is equal to literally just I. I. Oh, no, that's fine. You're not going to want to do this either. So just like int list equals 0 first, and then do int list of I position. Cannot assign to function call. Seriously. Is not less of a problem. IDE error. Come on, man. Alright, you don't want to play this game either. Cool. 4. I less than n. Nope, 4. While I is less than n plus 1. Alright, here was my other thought. We could try this. I think this will actually work, which would be nice. What we do is we say, okay, I is going to be 10. No, I is going to be 11 because we already know what the product is. Product equals 0. No, product equals 1. And actually, we already know that the product from earlier is 2520. Okay. This is going to be ridiculous. You know what? We'll just do it. It's fine. LCM prod. So, what we're going to do is we're going to say while I is less than n plus 1, the number we want at the future there, we're going to take the LCM of the current I and LCM prod. And that is going to be equal to LCM prod math dot LCM. What the hell? What are you doing? I don't know what you're up to here, but alright, cool. Alright, so then we want LCM prod. Clear. Nice. Okay, so again, we need to test first and say, do we get, with 10, do we get 2520? Oh, that's bad. That's very bad. What, what happened? Cause I picked 10. Alright, we need to debug. Because I don't know what that was doing. Okay, 10. Oh, we need to put breakpoints in. Of course we do. Editor Yofer, how's it going? Yeah, we'll just do that as a breakpoint. That sounds good. Let's rerun it. Ooh. Nope, 10. Alright, LCM prod is 1. I is 1. N is 10. Therefore, the LCM is going to be 1, because again, it's just the number 1. Alright, step over. While I is less than n plus 1 should be true, we get our LCM prod. We're going to increase I. Oh, of course we are. We didn't actually increment I. You know, that's fine. Alright, is there I++ in this? I forget. You should use a for loop. I don't know, everybody I've ever heard has been like, no, don't use for loops, they're terrible. But at the same time, you know. Plus equals, yeah, okay. Okay, let's try that again. End. Excellent. Okay. Smallest positive number divisible by all numbers 1 through, well, 1 through n. Let's try that again. And this time we don't need to debug, we can just run it. $25.20 exit. 1 through N, nice. Although it did double space apparently. That's weird. Run it again. Cool. Alright. So we got the answer for... Hey. Major Finger, how you doing? Yeah, pretty much. Doing alright. We're trying our hand at the Euler project. So if you have any interest in math and or programming, this is one of these interesting things that I would suggest, like, does really help your math programming skills, and like both mathematics and programming at the same time. All right, let's rerun and do 1 through 20. That's big. I know that they were going for that, but still. That's going to be here. Okay, so we're going to check our answer, which was 232,792,560. Nuts. I'm not signing it. Alright, try it again. Yeah, that number. Check. Woo! Alright, so, like, this individual problem is not a particularly difficult one. It's just that, you know, it sometimes tests your actual ability to do some of the mathy type stuff. Yeah, just not together. That's fair. True. Yeah. So Edariofer, yes. The only problem that I had here was, how do you actually get that into a program to do it for you, to generalize it? Because yeah, I could hard code whatever I want into, you know, MATLAB or whatever, and just say, hey, just multiply the... I could just get my calculator out, right, and start typing in a bunch of numbers. And this is only 232 million. It's not going to overflow the memory or anything like that. Like, that's fine. But at the same time, it's kind of like, okay, well, I know that I could do it on just my phone calculator at this point. Getting the answer isn't necessarily even the issue. It's, how do I challenge myself to say, like, do I really understand, in this case, Python? And at this exact moment, the answer is, yeah. I was going through all sorts of convoluted ways to do this, and, like, you don't have to. I was just going in this one. I was standing in the shower this morning because I had thought about this problem last night, and I was like, okay, I can build an array, and what I can do is I can get a list of all prime numbers. But here's the thing, I'm not going to make the list of just prime numbers. What I'm going to do is I'm going to make a list that's the exponents of the prime numbers, because you don't need the numbers themselves. You just say, how many of each one of these things do I need? Right? I can make a prime number list in Python by saying, like, you know, math.prime or something like that, and it's just an automatic list of the first n prime numbers. So there might be a little bit harder of a trick to that, but whatever, it's fine. So I was thinking to myself, like, that's easy enough. I could just make a list that is the exponents of all the individual prime numbers, and then it just reads off, like, you know, take the number in the prime list and then raise it to the nth power in the exponent list, and then go through and do that, and then we end up with the right answer. And then I was thinking about how to do it, and I'm like, that seems kind of hard. And then I went, wait, I just need the least common multiple. So I was like, well, obviously. So we go in here and we say, how do we do least common multiple? So it's math.lcm, but you can only have a list of integers in order to do that. So I first tried to create a list that went into the math.lcm function, but it doesn't read lists. It reads lists of integers. So I was like, how do I make a list of integers? And then it was like, well, just friggin' make a list by, don't even do it. Just do two things at a time and do a while loop. It's fine. It doesn't matter. It takes a quarter of a second, if that, to get the first, like, 1,000, so whatever. It's fine. In fact, right? Let's do it. Bing. Not even. Right? Not even a quarter second. If I were to do that, I would copy paste it. Right? So like it's a matter of how do you do these things in this particular programming language. I don't want the answer. I want like the generalized path for Python. I've done this before and made it to like, I don't know, 20 or something like that in MATLAB. Because MATLAB is designed to do math. Python is designed to do programming stuff. So it doesn't always match up with exactly what you want. Oops, I gotta move that over here. It doesn't always do exactly what you want. But it does get pretty close most of the time. Okay, so we'll go like this. Everybody can still see everything at this point. Good. Okay, so Project Euler, I need to iterate this up to problem number 6. Bing. Okay, archives, problem 6. Sum square difference. Sum of the squares of the first 10 natural numbers is 1 squared plus 2 squared, etc. equals 385. Sum of the square of the first 10 naturals is... the square of the sum. There we go. Hence the difference between the sum of squares of the first 10 naturals and the square of sums of the first 10 naturals is going to be this thing, 2640. Find the difference between the sum of squares and the first 100 natural numbers of the first 100 natural numbers and the square of its sum. Okay, so mathematically, we can find the sum of integers and the sum of squares very easily. But again, how are we going to do it in Python? Alright, we want... Let's close out some of these, maybe. Alright, new Python file. Project Euler 0006 .py. EU. Rename. Rename? Oh, crap. Please tell me that I can just rename this and don't have... Oh, yeah, there we go. Please tell me I can just rename it. Yeah, there we go. PREU. Refractor? I don't like the look of that. So, this is find the difference between the square of the first 100 integers. Nope. Sum of the squares of the first 100 integers and the square of the sum of the first 100 integers. All right, import math, as always. Right, yeah. So you could do a formula if you know the formula, or you could say like, I'm just doing this as like a, I'm just doing this as an exercise. So you can actually tell it to find like, what's the sum of the first 100 integers and just go with it. Now I think we're going to run into the same problem that I did last time, which is that if I want to do like, you know, what's the list of range 1 to 10? Interesting. Okay. So we need to do n plus 1 at the end. Int list equals, we also need to input again, we want the same sort of, oh, wait, hang on, n equals okay. Find the sums of numbers up to what? Or the find the sums of the first whatever. All right, so we want an int list, which is going to be just the list range 1 to n plus 1, right? And then we want a square list which says that we want to square each of the individual numbers inside the int list. So next question, right? Are we allowed to just say, okay, so this is going to be, I'm just going to do intel here, and then say we want like intel squared? No. You know. Alright, can we do what MATLAB wants? No. No, what the F are you doing? Stop. Alright, so over here we say in Python pointwise multiplication. Otherwise, you could do numpy, but I don't have numpy. Yeah. How to raise the power element wise. Again, that's going to be numpy. Cool. No. Okay, so we can still do this as like an individual point-wise thing. And then this is going to yell at me again, isn't it? Yeah, we just got to do 4. For I, where I equals. I don't remember how to do this, and we're just increasing the number of that's great. Python, we want, what is this? 4. Okay. I'm going to be back in a few minutes. We're going to get up, stretch, do your usual, cycle the water, do all those things. Should be 3 minutes, might be a little bit longer. We'll see how it goes. So, be right back, everybody. Enjoy the tunes. Alright, we're back. Sorry about that. So we're looking at trying to create a list of the squares so for I goes from 1 to some future number. How do we do 4? Ugh, come on. 4 target list in expression list. Okay. Try in range 1 n plus 1. Do not like that. Ah, right. We need to do int n equals int n. Right, so apparently we need to initialize square list is equal to 0 initially, and then do that to it. Okay, so then once that's done, then we say we want to take the difference between I can't read that. Right, the sum of the integers squared, so 1 through 100 squared is our int list, sum of our int list, and then squared. Okay. Difference is going to be equal to sum int list squared minus sum of square list. Maybe? What do you want? What do you want? Okay, and then here, print difference in square of sums and sum of squares 2, comma n is, and then we get that. Well, let's see if it works. Run. Okay, so again, nope. So debug 10 missing parse. What in the hell? Oh. Wouldn't have worked anyway, because I didn't put a thing in there. Okay. Let's go back to number 6 here. We need to put a dot here. Stop there. Okay, square list is just 0, so we haven't done anything with that. And then step through, we should get the int list 1 through 10. Okay, that's what we wanted. For I in range 1 to n plus 1, I is 1, n is 10, square list is 0, error. List assignment index out of range. Ah, crap. I is 1, and this is the issue. So, square list 1. Okay. Square list is 0. Oh. Do we call? What is intel of 1? It's 2. Of course it is. We start counting with 0. Alright, 0 to n. Why? But I fixed it. And obviously not, but okay, so again, we make the int list. I is going to be 0. Okay. I is 1. Has a problem with trying to square. Oh, and then it's assigning it to nothing. Okay, hang on. Okay, so no. Okay, so we can do zeros in much the same way we can do MATLAB. So if we say square list is equal to zeros, Nope. 5. Yeah, it doesn't know what I'm talking about. That's interesting. So we can do this as an array and say this is going to be 0 times, I don't know, well, I mean, we've got like whatever, but okay, yeah, this can do it. So this could be 0 times n. Alright, now let's try it. Give me the first 10. 6, 7, 8, 9, 10. Cool. Int list. 1, 4, 9. Yes, there we go. Cool. 2640. Is that the exemplar? Yes, it is. Oh. Okay, so now we do it again. Oops, no, we don't need to debug this time. We should just be able to run it. So we want the first 100 numbers. And I need to input that actual... I'm fine. Oops. Run it. 100. A. Alright. 25,164,150. Bam. Alright, we got it. Good. 10,000 first prime. Alright, 6th prime is 13. What is the 10,000 first prime? And we'll get that pulled up on OBS. Okay, so I think there is a prime. I think there is a primes function. PREU0007. Nope. Okay. Okay. So, how do we find prime numbers? Right, 2 is the first prime number, being important, not 1. We have a problem with 1 being classified as prime due to the fact that if we attempt to let 1 be a prime number, all possible future numbers cannot be prime themselves. They're all composite. So one way to look at that is through the sieve of Eratosthenes. Eratosthenes was a Greek mathematician who lived, way, way back when. And he said, if I take a list, make a list of all possible numbers, and then we say, all right, anytime that I find a prime number, I'm going to cross off its multiples everywhere from here on out. So naturally, if you cross out 2 as a prime number, then you're going to get every even number. So 2, 4, 6, 8, 10, therefore 2 is the only even prime number. If you were to cross out 1 as a prime number, then that eliminates all possible numbers after it. So we say, okay, well, 1 can't be primed by that argument, and it also can't be primed by a number of other arguments that mathematicians and number theorists have been yelling about for millennia at this point. I find the sieve of Eratosthenes probably the easiest and most elegant in terms of just simplicity. It might not be the most rigorous definition of primes, but like, whatever, it's fine. Okay, so what we can do from here is we say that we're going to create a list called primes, and it's going to be right, it's going to be n long. So we want, again, n is equal to the input of this particular prompt, and n is then going to be an integer of n. Prompt is that or which prime. Alright, so our primes list is going to be 0 times n. That's how long we want it. And then while okay, I don't want to do this in n squared time. So that's what's going to happen if I try to say, like, you're on a particular number and then try to divide every number less than its square root, for example. As we get further and further along, the process is going to take longer and longer to do. We could create a sieve of Eratosthenes and say, like, we're going to eliminate all numbers after. There's no guarantee it's going to fill up. So Right, so if we start with a candidate list that's like, you know, n squared long, and then start eliminating them as the sieve of Eratosthenes works, that's not really going to work. Size of a prime ends up being like exponential. The size of the primes is logarithmic, so leaf blower. I'm going to append these. So this might be completely psychotic, but I'm going to say that we're going to take the first primes and just use them. 5, 7, 11, and 13. So we're given the first 6. Right? And then we're just going to add on n minus 6 zeros onto that. I have no idea whether that's going to work, so let's try it in the console. Primes is equal to, right, 2, 3, 5, 7, 11, 13, and plus zeros times 3. Primes. 2, 3, 5, 11, 2, 3, 5, 7, 11, 13, 1, 2, 3, 4, 5, 6, and then 1, 2, 3 after. Cool. Alright. Okay, that's going to work. That'll do it. That'll get me exactly as far as we need to go. So, I is going to be equal to 6, because we have 6 already. And then while... No, we know... People have been saying, like, don't use for loops, and I don't know. The fact that I want it to iterate once, right, to do something once, kind of precludes this notion that, oh, I should go and... that I should, like, do a while loop because it's going to be better or something. I don't know. I'm going to do a while loop, but then I'm going to stick a +1 at the end for, you know, I plus equals 1. Like, it just doesn't make any sense. Using a for loop makes much more sense because I want to do one thing and then I want to iterate my I. So for I in range 6 to n plus 1. Is it 7? Oh, but it's not even... Yeah, it's a local variable anyway. It doesn't matter. I don't need the equals 0. I don't need to initialize it. It's not a while loop. Okay. So I can just take that out. That's fine. So while we're going from 6 to n, I think. We want... Right, so what's primes 6 is 0. Primes 5 is 13. Okay. So we want to replace primes 6 with the first prime that we get. Okay, now we want a while loop. Because what we want to do is we want to say, while j divide... while the we want j to start as the last, or like the last known prime that we've got. 13% 2 is 1. 13% 5 is going to be 3. Cool. Yeah, I've got it the right way around, so that's good. Right, because if we try to do 513, that's going to get us 5. Yeah. So j percent okay, j percent what are we trying to divide by? I mean, really, we want to divide by anything. We want to divide by all of the other... like, we want to compare it to everything in the list so far. This is not going to work. 13% primes. One, two, three. Yeah, we're not going to do that. What are you trying to do, Obi? Come on. Okay. So we want a for loop to go through every single possible value. We also want a for loop. Okay, and I'm going to have to change the J for any other context. In range. So we're going to have to make this K instead. Oop. What did I just do? No. Well, this K. Oh, okay. Do you want to rename things? Yeah. So for J in the range of we only need what is primes 1 through I. Oops. Yes. Okay. So going through all of the primes that we have before, except 2, because we know that there aren't going to be any other even primes, so F it. We'll just leave off all even numbers. K starts at 13. Okay, so K starts at 15. And we already know that that's ridiculous, but whatever, it's fine. If it were 13, right, we would get a 0 remainder when we divide by 13, and then that would try to add another 13 to the list, so we don't want to do that. So technically, right, we'd be like, okay, let K equal 14. We're not going to let K equal 14 because we don't want even numbers at all. So start with 15, which we know is ridiculous, but whatever, it's fine. So K percent primes at the ith position? No, jth position. Is greater than 0. We just want to do K plus equals 2. So just keep going up, right? We'll just keep increasing K while... No, not yet. Crap. No, wait. We want that for loop. We want the J for loop inside this. Alright, this is... Whatever. I got stuff backwards. It's fine. Okay, so while this is going on, we say, let's do a for loop. Let's do a for loop. Which is going to run through all possible values of J until we get to I, which is our current position. Okay. If gotta figure out order of operations for this. I can't do that either. I can't call the... Because I want... Arg. Okay, so for j being in the range of 1 to I, we're going through and we're iterating and we're saying every single time we want... Okay, this is fine. K plus equals 2 on the outside of this, and it goes back in through the J loop. Does it? Oh, this is going to be frustrating. Alright. So we're going to be at the 6th position, which is a 0. We're going to run through all of our j's, which are going to be the individual values in primes, all the previous primes. And as long as... I think it's going to be on the next line then. On the eyelet. On the eye line. Right, so... So I want it to be... Alright, so p equals 0, it's going to be like our prime indicator to say whether a number is prime. Now again, maybe this is ridiculous, but whatever. So, for j in the range of 1 to I, again, primes of 6 is going to be... Primes of 6 is going to be a 0. That's going to cause a problem. We want this to be j minus 1. That's not true either. Damn. Arg. Oh, yeah. We do want this to be j minus 1. Because we want this to be everything up through... Damn it! No, okay. We want this to be I minus 1. There we go. Whee! Okay, so I starts for 6. Yep. Hey, Cold Gold. We're doing the Euler project, or Project Euler, up there. So this is the This is problem number 7 that we're working on. We're trying to find the 10,000 first prime, and I've done this on MATLAB out through like problem 20 or something like that. And the point of this is not to find the answer to the question so much as it is to expand our ability with a particular programming language to try and figure out what the answers are. And very specifically, to try and program a generalized solution for any particular problem. So in this particular case, what we need to do is say, are we now able to find any prime number that we want based on some n value that we're given? So how far do you want this list to go? I should be able to run that in this program, no problem at all. So far, it's quite frustrating, but you know, we did 5 and 6 earlier today, and that was number 5 was what is the smallest positive number that is evenly divisible by all numbers 1 through 20, and again 1 through n, whatever we want to find. And number 6 was find the difference between the sum of the squares of n, 1 through n, and the first, in this case it was n was 100, and the square of the sum of those first n integers. So you're taking, 1 through 100, summing them up, and then squaring it. And then we're subtracting that from 1 squared plus 2 squared plus 3 squared plus ... all the way through 100 squared. Since those are bigger. Alright, so we have found oh, right. No. The sum of the individual squares are neglecting the cross terms of the sum of all integers then squared. So the sum of all integers then squared is going to get us a larger value. That's what that is. So, looking at what we have. So we figured out how to do these individually fairly easily. Again, these aren't like hard problems, but the point of it, again, is not really to get the answer so much as to try and work out how to get the answer in, again, this particular programming language. So I haven't really touched Python before, a few projects here and there, which just are little things, mostly within math. So this is the first real foray we've actually done here. I don't know, man. I'm just trying to do this friggin' what are you doing? No, I know you've got a problem with just an A sitting there. Okay, so what we're trying to do for this one, again, is just to find the nth prime number. So here, what we're trying to do is say we want to find a remainder for where we are, right? K is going to be our current test value that we're doing. Obviously, I could start with 17. That's not the point. We were given the first primes out to 13. And then I said, okay, look, we're just going to check odd numbers. We know that there are no even primes. So we'll test all odd numbers starting with 15. Despite the fact that we know it's not going to work. It doesn't matter. And then what we're going to do is we're just going to iterate by adding 2 every time. And then what we need to do is say that our k is going to be tested against whatever prime number we're on now. And as long as it has a remainder that is not 0, then we're just going to iterate. So is that return? That's not return. No. Break. Skip optional else clause if the loop has one. Okay. So primes is going to start with the given, which, as you can see from the prompt, right, it gives us the first 6 prime numbers and says these are prime numbers. So the first 6 are 2, 3, 5, 7, 11, 13, of course, and then we add, or this isn't just a simple like addition. This is oh my god, what is the proper word for that? A join. It's not. Append. There's a better word for it, but yes, thank you. Concatenate n minus 6 zeros. So there are going to be whatever your n is for how many primes you want, right? So our test value is going to be 6 on this, and so it's not going to append anything. And we'll see if it comes out with the actual appropriate value, which of course it should, but nonetheless. 15, oh man, that's going to break it. Okay, we'll do something easy and say like, what's the first, what's the 10th prime? Because we know what the 10th prime is. It's nice and easy. We can make sure that it follows the right rules. Okay. So we do while break. Right, and then, oh, okay. Separate it, I guess. I don't know. Oh, that should be in that one. There we go. I don't know where those lines are supposed to be. Anyway, okay. Okay, so if, maybe I just need an if. Because I just need like one moment, right? If somebody's going to yell, that's fine. If is equal to 0. Then what we want is that k should be appended, or should be placed in. K should be equal, no, primes j should be replaced by our k value. Else break. No, that's not what I want. That'd be nice. Is it just not, like, recommended? Okay, so how would you say this? How would you say, like, if we find something where the right, where the remainder is 0, then we're going to replace our current location. That's not it. It's prime's I. Oh, no, wait, hang on. Nope, that's wrong. If it does divide, right, then we want to skip. Then we want to go to the next j. That's wrong. And yes, please let me know. Else. Yeah. Else if, because else if isn't a thing. Elif. If I equals j, then we want it to so here's the thing, I need, well, actually, yeah. That's right, isn't it? Because we need to this equals 2. Because we need it to, we're going to say forget it. We don't need this anymore. Just go to the next k. Yep. Yep. Okay. So we can get rid of this. Good. So if I is equal to j, so we're at, it can't be equal. Damn it. I minus 1. Right, if it's still not equal, if if k still does not divide primes at j, and this is our last position, then this is a prime. So primes at I is going to be equal to whatever the k value is, and we need to iterate k And then it's going to terminate automatically, so we don't need a break. In theory, right, this should work. Famous last words every single time, man. Let's do it. Let's go! Okay. So, elif is an else, but it has a condition, right? It's else if, but which, like, sure, in theory, this is the only time. Oh, no. Hang on. So we don't care about it the rest of the time, right? If we're in a different position in our primes list, we want to continue working through the primes list. So we need our j to iterate. Okay. So we need some breakpoints. All right, let's find the first 10 primes. That did not do what I wanted it to. Oh, that was not the right one. So we need to do 7. Current file. Hey, what do you know? Which prime do you want? 10th. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be the last one. Cool. Got all that stuff. I is 6, J is 1, K is 15, N is 10, P is 0. Yeah, I might not need P at all, so. Okay, so K is 17, because 15 didn't work, although I didn't see it, I guess. That's slightly annoying, maybe, I don't know. Whatever. It's fine. Iterate back. I7, K17. Uh-oh. J's 2, so that's 3. 5. 7. And I don't actually need to divide by everything. It just needs to be... Ugh. The number that's there needs to be less than the square root of the number we're testing, of k. That's fun. Uh-oh. Uh-oh. Oh. Oop. Crashed and burned. Yeah, there were some problems there. I clicked too many times. It did not overwrite. If j is equal to I minus 1, primes at I was going to be equal to k? I'm not going to forget everything you said. It was still valuable. J in range 1 to 5. Primes. Five is 13. So that's like the last one we're checking. Grr. But it's a for loop. Or do you mean so that it's checking the first item in primes? Because again, since it's 2, I just said let's skip that one. I feel like it should have broken the for loop, in which case it goes back to I, iterates, and starts over with j. Let's see. Which prime do I want? I want the 10th prime. So that, wait a minute. It just skipped. Alright, that's messed up. J is 5, K is 17. 17 is trying to be divided by all these things. Primes 5 is, that should be it. Right? It goes back. 6. It should have made it to 6. Here. That's weird. 7? 7. Yeah. Okay, should be equal to K, which is 17. So we should set that equal here. 6 if J is equal to, but it didn't make it there before it quit. All right, I don't think 0. That's weird. Yeah. Okay. So it might have jumped back to there and said, oh, debug. There we go. Might have jumped back to there and said that we got 5. 0, 1, 2, 3, 4, 5. At 13. Okay, so J gets set back to 1 here. Yes, okay. J gets set back to 1. We're good there. The issue is, I think, this J equals I minus 1 might need to be I minus 2. Because we're calling it in 2 different ways. So we're calling J as a range. But I is also a range. But here we're calling it a position in the list, which I think is messing it up. Okay, so let's do something crazy. Excuse me. and stop and try again. I want the 10th prime. Okay. Aha, we made it. Oh. I minus 1. Here. Try again. Okay, so k goes to 19. Go through the process again. Find it. 19. A. Go through 21. 21. Well, that didn't do it. Print. No. There's N? Maybe? Alright, this did not do what we wanted it to. It only went to... That's weird. Why? It can't iterate I unless it's written. That's why it's -2 and -1. Because it doesn't know what the hell it's doing. It's only using I as like the numbers that it's checked. It's not... I said 10th. It should have come back with 0, 1, 2, 3. Didn't even come up with the right... Alright. Really? Oh. That's not parentheses. A. Right. So, we've... It's wrong, but... but at least it didn't throw an error this time, so it's an improvement. Alright, so we don't want it to break to I. Okay, I got you now. Okay. You're right. We do want it to reset J. Reset J to 1 if... Hang on, wait. Yes. And we only want it to increase I if that other stuff is true. Okay, let's try it now. Because I think more or less this... Well, okay. No. 10th prime. Okay. Rewrite. Come on. It rewrote it. Or it overwrote it. Okay, so now we want this one to be I minus 1 and this one to be I think. I didn't change that though. 13, 17. Oh no. Really? But all right. So this being -2 and this being man. Why does it not read my mind and do what I want it to? Alright, so we increase to 17. This says fine, we'll just keep moving this. Placed in. Now it should increase I now. And K. 7. J1. Okay. Now we go through and we try to find what's going to match here, what's going to get us the exact same thing. We don't find any. So then it adds 2 to here, 21. We already added, okay, we added 19 in the appropriate place. Add 2, we get 21. Reset J. No. Iterate I, because now we've got something that is in that position that's not 0. I mean, that's not part of the question, but we just added something. So since we just added something, it goes back and iterates I. I becomes 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Cool. We're now on a 0. We go through. And now J1 was 3, which does divide 21, so that's out. So now we iterate K to 23, and this is prime, so it should go all the way through to 6, right? Place it in, iterate K. This should get to J2 before it fails, and then resets. Iterate I, reset J, doesn't divide, does divide. So now J reset, K reset, 27. What just happened? 0, 1, 2, 3. We're on 7 now? That doesn't make any sense. Is it just... What the hell happened? Reset... No, reset J. What the hell? Alright, I need to go back? We can't go back. What just happened? Did it reset to 1 and then automatically get increased to 2? That was weird. 27's not. And we already filled up here, so yeah, no. Okay. So if we reset it to 0, is that gonna be better? Debug. 10th prime. It just iterated to j equals 2. What the absolute crap? It automatically iterated, but it did. Okay, so this needs to go in, right? Step in, j equals 0. It was on j equals 2. It's automatically on j equals 3. Can you reset a for loop while you're in a for loop? Because again, I just tried to, and it took j and set it to 0, but then it How do you do that? Is there a thing? Is there a way to do that? How about you use a while loop? Man. Ooh. That wasn't what I wanted to do. Serious? I mean, what do you... What the... Okay. Alright. This thing really freaked out at me when I tried to do this, so what happened? Oh. Pfft. Just unmatched parentheses. That's not a problem. Wow. Okay. Debug. I want the 10th prime, and I didn't put in any blocks. Cool. Yeah, you're freaking out about that too. What do you want? J can be undefined. Okay, so initialize. All right, what warnings do you have now? Oh my god. White space after commas. All right. White space around operator. New line and file. Woo! Mr. Eldritch. Good morning and welcome. My name is Obi-Wan Piz. This is N Simplex Pachinko. We are currently working on some attempting to get yelled at by Python as many times as possible. So far, going pretty well. You know, I'm usually the one who's like yelling about wanting all the white space in here because just like it, but yeesh. Alright, what you got? What's your last freak out? One warning. Unused statement import math, because I haven't used any math. Cool, cool, cool. Okay, so we cancel this. We're going to say we want to use number 7, debug. We want 10th prime. 10th prime is 23. Okay. Give me the 30th prime. 30th prime is 63. 30th prime number 113. So, no. Wow. That failed spectacularly. Damn it. Alright, so what is it that it's doing this time? Yep, well, so this is Python. We've been trying to work on Project Euler, which is that series of prompts that is just basically a challenge for people to test their math and be able to test their programming abilities. My math's pretty decent. I've got a master's in applied mathematics. My programming has always been sort of, and I've done this in MATLAB through, and it's been many years, but through about problem 20. There's a whole bunch of much easier ways to do this in MATLAB because it's used to doing math. This one, yeah, not so much. Alright, so we do 10th prime, right? It's going to step through. It says that primes at 1, position 1 is 3, will divide 15. So it goes, we get 0, and then it adds 1 to j. We've also added 2 to k, so it becomes 17. Been in for 2 months, but this is your first time chatting, so welcome. Thank you for lurking, by the way. Alright, so 17 is going to fail in terms of it's always going to be prime, so this is fine. Right? Oh, does it need to be j minus or I minus 1 now? Ooh, that's a good question. So this is going to be 1, 2, 3, 4. Yeah, it needs to be I minus 1. I've been going back and forth on this for a while, so it's just going nuts. Excuse me. Wait. But while it... man. While it's less than... oh, less than I. Yes, because j at 5, or primes at 5 need to be included. Okay. I think I got it now. See how this goes. Okay, so k iterates to 19. J iterates to 5. Uh-oh. Uh-oh. Yeah, this needs to reset j to 0 as well. Okay. Now, good news, 19 is also a prime number, so it's not going to be an issue. But... okay, so 19 gets added in, j gets reset to 0, which didn't happen before. K now increases 2 to 21. Crap. Yep. So... j doesn't iterate. Damn. Okay, so I need to exit and try again. 10th prime. Da, 17. 19 should be good. Ugh. Damn it! I overwrote it. 2, 3, 4, 5, 6. I didn't iterate this time. Minus 1. If it's equal to minus 2. Damn it! Overwrote it again. It overwrote it again. Why isn't it iterating I now? What the hell? Yeah. Awesome. Again, thanks for stopping in. It means a lot to the math community here on Twitch that, like, people just show up. Because just showing up is going to be a big deal for for all of us. All right. So, is that what it is now? So if I do this, then I need to break. I think that's what it is. Okay. And Yeah, I know. Uh, I know you've got some, or no, gold. I know you have a thing against break, but nonetheless, we're gonna see if this is gonna just fix everything, because, you know, might be nice. That was actually the correct one that I wanted to do, but it's fine. Step through. Okay, so 17 goes in the right place. Does 19. Yes. Does 21 get skipped? Yes. Does 23 go in the right place? Yes. Does 25 get skipped? Yes. Does 27 get skipped? Yes. Does 29 get placed incorrectly? Placed in correctly. Yes. Tenth prime is 29. Alright, now I know for a fact this should be right, but let me just double check in case. Yeah, it's good. Okay, so let's go with 100th prime again. Is 541. So, next question. If I do the 100th prime, do I get 541? Yes. Okay. So now we need... Hang on. I've got a list here. What is the 1000th prime? It should be 7919. Yes. And we get 100,000th, which may take a minute. It's 1,299,709. Is that 100,000? Yeah. Oh dear. Might take a minute. Two order of magnitudes back, and it only took, like, you know, a quarter of a second. I saw it delay, and I should have realized that that was probably going to be a bad idea. Oh. All right, we're going to break. Oh, no. Oh, wait. Nah, it's still just running. Okay. Okay. So we want, actually, the 10,000th and first. Which, again, may take a little bit of time. But hopefully is not going to take... There we go. 104,743. Sign me out again. So, remember me this time. 10,000 first prime. That number. Yes. Alright, cool. So we have that one as well. Now, we're going to check, let's see, browser. Iterate, problem number 8. Boop. Oh. Oh, that's gross. Love it. Nope. All right. Archives 8. 4 adjacent digits in the 1,000 digit number given below have a greatest product are 9989. 9989. Can't even see it. It's fine. Yep, there it is. It's about 2/3 the way down. I can't see. Anyway, sort of on the slightly left of center, about probably close to the bottom of this one, on the line that starts 82166. Yep, okay. Yep, anyway, that's a 1,000 digit number, although this does actually keep going, because we just don't have... You know what, let me increase the height to 1,000. Yeah, there we go. Finally, 13 adjacent digits in this 1,000 digit number that have the greatest product. So this is a number. In order to do that, I'm thinking we need to turn it into a list. Yay! Let's see. Done this before at some point. Map. That could work. Oof. Okay, so I need to copy this ridiculous number into a new Python file. PREU0008. Comment. Ugh. So find the 13 consecutive numbers with the largest product. What is the value of this product? Okay. So with this, we're going to say that we want to the number itself is this thing. Okay. Oh, that's going to be a problem. Okay. E501, line too long. 1007 characters is greater than 120 characters. So good question there, I guess. We can split it up as just strings, and then concatenate. Alright, can we just do math on this? So, let's see how it is. List num is equal to list of map of int, comma, string number. Does that work? Hell, I think it might. Okay, so we're going to do the same thing as the example, which is that we're going to take some number, which is going to be our input. Whoa. Oh, that's not fun. I turned my head slightly sideways. It was like a gyroscope. Like, I'm super dizzy. All right, cool. There we go. We're good. N equals input. Give me, what is the product? We want the product of how many consecutive digits? So in this case, we're going to enter 4 and see if we get the same answer as we did from the other one. All right, so then we say, yup. Oh, my kid yesterday was like, hey, lay down in the this spinny ride thing. And it's just like, you know, the bowl ride, where like she had tucked herself in and like got me to spin her about as fast as possible. I was like, all right, cool. So then I just kind of like laid in it like that, and then she spun it, and I got to go on to maybe, I don't know, a tenth of the speed that she was going, and I could just feel the negative G's forcing all the blood into my head and my lunch into the top of my stomach, and I'm like, nope, 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 nope. That was no fun. Okay, so here's the thing, right? We're gonna run this and just say, all right, 2. Cool. We primed this, so in theory, it does work. Yeah. No, I mean, I don't think it's just me getting older and my inner ear being less happy with me. Like, it's been slowly building for a long time, and yeah, probably it's just not great, and maybe the fluid is starting to get thicker and harden, because that happens when you get older, too. I got to see the GP anyway because I haven't been to one in a few years, and I need a tetanus shot. Weirdly enough. So as soon as I get off stream here, I'm gonna go do my rounds of calls that I need to do this morning. Okay, so what we want. Okay, so what we want is we want to take the first 4. Okay, so while initialize I is equal to, so our I is going to start as n. So whatever n, oh wait, we need that to be an integer, as always. N equals int n, not, jerk. All right. I is going to start as n. So while I is less than size of list. Nope. How do you do size of a list? Length. Length of list num. Colon. Yeah, I'm not saying that my dizziness right this second is contributing, or it was contributed to by that yesterday. It's just that, you know, it was something that happened yesterday, and also me just tilting my head like that was spinny, which by itself is not necessarily good. I understand. So we're going to say well, I is less than the list num. We want to take the if prod n is greater than run prod. So we're gonna get 2 things in here. Prod n needs to be just 1, and run prod is going to be 1 as well. Okay, hang on. Okay, so I want my running product to be equal to 1 at the beginning. No. Ah, shit. Okay. So I want my running product to be initialized as the product of what's my list? List num. Of the digits 1 through n. Okay. Or first position through nth position. That's not really helpful. Ugh. Okay, so it can be 1 first. Then 4. I in range n to the length of list num. I do have a lot of pasta downstairs. Bonus. It is also 1 o'clock. I should probably eat something. It's my fault for starting stream at 10. So, okay. Alright, so 4i going from the range of n, which is what it was initialized at. And, man. So I don't need to initialize it if I do that here. Then what I'm going to do is I'm going to... Why did the music stop? Cool. We're playing this game again? Jerks. Alright. So drop pretzel, pull the history back. Hit next. Cool. It worked. Okay. So we say that I is going to go from n to the length of list num. And in doing so, we want this to multiply together. Run prod is going to be equal to previous run prod times list num No, I'm initializing. From 0, because that's the first position, up through n minus 1, because that's where we're at. That's how many numbers we're multiplying together. There we go. Okay. So that's going to initialize the running product. And when it's done, I want the highest product to be equal to what we just got as an initialization. Then I can be set to be equal to 1, or n, damn it. And then, while I is less than the total length of the number itself, we essentially want to run that exact same thing, but for all individual sets of numbers. Okay. Let's not use I in both places, right? If anybody does have any actual math questions, by the way, you can also just ask me, and I can put this on hold for a few minutes. So, see how this goes. Okay. Define calamity. Nice. I'm asking you for any. So we define one prod of, yeah. Okay. Take this out because it doesn't need to be here. Do we go like that? Is that possible? Typo. Run prod of, what are we taking in? What's the variable we're using here? Yeah, it is I. Okay, so we need this I. To be the number of digits, number of consecutive digits we want. Oh, that's our position. Damn. N. There we go. I don't need this if it's already done there. That's fine. Alright, let's define function run prod to do a loop that is n minus or n terms long. starting from position 0, going to n minus 1. Can I take in list num without calling it? Yeah, last not callable. There we go. Argument name should be lowercase. Punk. I'm glad that music fix really worked. Alright. No. N. Okay. Yeah. So, running product. Well, it's not what it is, right? So we should not use this. How did we do functions way back when? And when we call the function, I did not call the function. Oh, there we go. Is palindrome. I just used whatever we had. Okay. Okay. Right, wait. And then we returned. Return whatever that's going to be. Is palindrome just returned either true or false, and then here we're going to return an actual number. Yeah. Right. Alright, so product is going to be running product, which we need to define first. 1. What? Fine, I'll indent. Is that also a colon? Yeah. Yep. Cool. Okay. Send those in, and then we're going to get out proden. It doesn't return anything just yet, because, yeah. What? You'd like to think that, wouldn't you? Alright, there we go. So, now we're doing this. Well, so in the world of Elite Dangerous, I fly a Python Mark II. But no, seriously. So I'm using Python particularly because it has a lot of like mathematical connections. C++ is all versatile and wonderful, but at the same time, like, it's not exactly the most user-friendly, easiest way to go. So, I don't know. Kind of depends on what you like. So far, I've liked Python. The only problem is that it doesn't automatically come with the mathematics libraries, which I can never get the hang of C++. I have edited C++. I've just never been able to program it myself. Python seemed much more intuitive, especially coming from a MATLAB background. Okay, so this is not done yet. For I in the range of 0 to n minus 1, we want to say that the product is going to be rprod is going to be equal to rprod times listnum I. We also want product to be equal to 1. And then we say if, nope. If after this for loop is done, no, I want the running product. That's fine. I don't need products here. That's all we're doing, right? We're just sending the running product back. Rprod here is going to be equal to the running product of this many consecutive digits out of listnum. That now can just be taken into this other part down here, right? Well, j is less than the length of listnum oh, and I need our current position. J plus n. Or no, just j? No. I need the whole thing. But I also need j. Oy. Our current position j minus I. It's like completely backwards, but alright, cool. It says, what is our current position? Take n value, the consecutive number of digits we need. Take the list, the whole number as a list, and then take j, our current position, and say we're going to do j minus I. Which will go from 0, so wherever it currently is, j, and then back some number of spaces. Okay, do this. And then if our prod is greater than our product, actual product. Product equals 1. Okay, so if the running product is greater than 1 in the initial run, which hopefully it will be, right? You got 4 different numbers that are being multiplied together. Then product should be reset to our prod. Else, so if that doesn't happen, is it not else? What's going on? Indent expected. Okay, fine. I'm writing it on the next line. What do you want? Aye. I guess we don't do anything really, anything different, right? The running product is going to just end up what it ends up as, and then we say, all right, just move on to the next one. So this is going to be j plus equals 1. Move to the next one. Okay, then when that's finally done, I feel like I'm missing one again. When that's finally done, we say print, we got final product of n consecutive integers, consecutive, digits. And produ. Doesn't make any sense. What are you doing? All right. Woo. You told me something about that last, whenever it was ago, but yeah. Visual Basic. Woo! It's just the best. Oh boy. Okay. So, we've got this humongous number. We're going to run it. We want the consecutive. Okay, we can check that. Really? You jerks. This is one of the problems with pretzel. Uh, 21 gigs of virtual memory. Gonna have to kill it. We're gonna end Firefox on SIGTERM. Okay, give it a second to clear out the cache. Yeah, I just don't have anything that's DMCA safe, so. There we go. Okay. So, 4 adjacent digits have product of 5832. So if we go with 4, yep, not possible. List object is not callable. So there's... right? So do we need the array? Sum of digits of a number, right? Okay. So it seems that list num here, this thing, is at least sort of okay, but I found something that's faster, so we will co-opt this one. Okay, list num is equal to r, where we can define nope, 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 nope. Define list. That's not what it, no. Ugh. Oh no, that's needs to be there. Hmm. Not important. It's not helpful, right? Hmm. Okay, so this says that we want to convert this particular thing into a string. Then find the list of map of integer, comma, strip. Individual character using strip method. It's an option. Okay. Seems like if we undo this stuff, dot strip. That's not it. Num string is the string that we wanted. So num.strip. In theory, nope. Int object has no attribute strip. List map int comma string that you want dot strip parentheses. Man. Alt Shift Enter, ignore all unresolved. No, it's still freaking out. So it doesn't like that. It doesn't want to do a strip method. don't do list. Str of num, allegedly. Nope, don't like that either. Oh, wait, extra. That's okay. Alright. Object of type map has no length. Applies the function int to each character in the string, turning each one back into an integer value. A list of these integers is returned. Okay, so where does that have an issue? Line 40. In line 40, length of list of listnum how many consecutive digits? 4. Nope. Man. Alright, I'm going to have to take a break on this one and think about it. In the meantime, we will head on over and find somebody who's doing some stuff. Very descriptive. People I follow. Who we got? Who's doing math? No offense to that person, but I've seen some of the stuff they do. I'm not really interested. Alright, so following, let's go and see Psyche, who is doing some New Vegas tonight, or today. So we'll pop on over there and say hi. Everybody bring some sort of cool, I don't know, bring some sort of cool, like, emote thing. Alright, we'll be back tomorrow for more math stuff, most likely tomorrow night, so add, give or take 8 hours. I got some calls to make, got some people to talk to, getting my stuff finally on Wednesday, so yes. Alright, in the meantime, hope everybody has fun. My name is Obi-Wan Pez, this is N Simplex Pachinko. Good day.